Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity for any x greater than 0. So press pause and have a go. Okay, so to do this, let's just say the limit. Let's just say the limit is y. So from here, natural log equally to both sides. So natural log here, natural log. This will then come down here. That will then give you this, your natural log, and then you've got your complicated bubble, So now visualize this as one fraction multiplying this block. This block here gets multiplied to the top, so that will then give you this. So now try and see what happens as n tends to infinity. As n tends to infinity, the denominator is going to head towards infinity. Let's just look at this bit. What happens as n tends to infinity for this complicated bit here? So let's just look at this bit here. So now, as n gets bigger and bigger, we can pretty much ignore this plus 1. It's negligible. As n gets very, very big, this thing here is going to be very, very big, and then you're going to add a tiny, minute amount. Let's forget about this one. It's negligible. So it really boils down to x to the power of n over 2n, which as n gets bigger and bigger, which will dominate, which will get bigger, well, you see, x to the power of n will get a lot bigger than 2 to the power of n if for example, let's say x is 3 here, x to the power 3 to the power of n would be, remember, n is getting bigger and bigger and bigger, n is heading towards infinity. So what that means is, let's just say x is 3. So 3 times 3 times 3 times 3 times 3 for the numerator. For the denominator, it's going to be, well, think of it as being like this. If n is, let's say 7, it will be 2 times 7, meaning 2 plus 2 plus 2. So you can think of it as being 2 plus 2 plus 2 plus 2 plus 2, and so on. You see, the x to the power of n will be a lot bigger than 2n. Even in the case of you selecting x equals, let's say, 1.003. You see, even if you select this, let's look at the numerator only. So in the case of x being 1.003, it's going to be 1.003 times 1.003 times 1.003. For the denominator, it will be 2 plus 2 plus 2, and so on. Eventually, the numerator will overtake this thing. Strange as it may seem, this thing is just going to grow and grow and grow. Eventually, as n heads towards infinity, the numerator will overtake the denominator. If you don't believe me, get a graph plot and plot 1.003 to the power of x, and then get a graph plot and plot 2n. 2n will look like this. This thing here, it climbs, but really, really slow. But as you get to, I don't know, maybe 10 to the power of, let's say, 5 or so, I don't know what. But this will eventually overtake the 2n. If even in the case of this 1.003, it will eventually overtake this thing here. So for n, for if you select x greater than 1, this thing here is going to climb. It will eventually overtake this. So the point here is that if x is greater than 1, this thing here will be bigger than this thing here. This thing here will grow, will overtake this thing here, meaning that this bit here will head towards infinity as n goes to infinity. So what's happening on the top? What's happening on the numerator is you got something that you're natural logging something that's going towards infinity. So overall, overall the whole block here will head towards infinity. So this whole block here heads towards infinity. This end here heads towards infinity, and then well, infinity over infinity is an indeterminate form. So you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this. That will then give you this, and then differentiate this. That will then give you this. Okay. So hang on. I will continue in the next video. Okay.